Hey everyone, this is an introduction to odd and even functions. We're going to look at graphs and values. Before we do that, let's look at symmetry of graphs. Number one, keep in mind at Socrative, if I ask about number one or number two or number whatever, that's what I mean. As we do these, you should pause the video and see if you can answer them yourself. This is symmetric about the y-axis. Let's actually reflect that here. See how the function reflects over the y-axis onto itself. That is fantastic. Number two, that's the square root function. You should recognize that this has no symmetry. That should be obvious. This is y equal x to the third. It does have rotational symmetry about the origin. And what that means is if you take the half on the y-axis, copy it, rotate it 180 degrees, and put it on the other half of the y-axis, it fits onto itself. I mean, that's fantastic. There is another way to think of it, though. You could reflect it over the y-axis, take that result, and reflect it over the x-axis, and it comes back to the original function. That's nice. All right, number four, that is the cosine function, and it is symmetric about the y-axis. We'll talk about what that means in a minute. And let's actually reflect that, see how that does that. And you're probably thinking, well, if cosine reflects over the y-axis, so does sine. No, it does not. It is not the same function. This is the division function. The division function is actually symmetric over this line right here. And so there's two answers. But for what we're studying, we want to say it has rotational symmetry. And if it would reflect over the y-axis to here, and then that would reflect over the x-axis to there. This is this sine function. Guess. We like guessing. It is rotational about the origin. Let's do it with the double reflection. If we reflect it over the y-axis, we get a totally different looking function. But if we take that result and reflect it over the x-axis, it comes back to the original function. That is nice. This is kind of a unique function. It is rotational about that point, but it's not the origin. And so the answer to that is D. All right, an even function is symmetric over the y-axis, and here are two functions that are symmetric over the y-axis. Let's look at that one, our old buddy, y equal x squared. Keep in mind that it reflects over the y-axis, which makes it even. And let's do some input-output with it. I mean, we just love to do that in mathematics. Let's input 2 and -2, 3 and -3. And clearly the outputs are going to be 4 both times and 9 both times with the 3s. See how the points reflect over the y-axis? But what we want to notice is that opposite inputs output to the same value. We want to be able to say that as a rule. In an even function, opposites output to the same value. And we can recognize this table as an even function table because the 3s are both outputting to -8 and the 11s are both outputting to +2. Even function. You might want to memorize that the answer to this is A. What that means is that the reflection over the y-axis is equal to no reflection at all, like it was in the parabola. An odd function is symmetric about the origin. Maybe a little bit harder to see. Let's redo this. We've already done this, but let's reflect y equal x cubed over the y-axis and then reflect the result over the x-axis, and we come back to itself. That's probably the easiest way to look at it. And the sine function, the same thing. We've already done this, so let's do it quickly. Reflect over the y, take that result, reflect over the x, and we come back to the original function. Let's do some input-output with y equal x to the third. Let's input -1, +1, -2, and +2. -1 is going to output -1. +1 is going to output +1. -2 outputs -8, and then an 8 there. See how the symmetric points go through the origin on a line? But let's do it as outputs. That opposite inputs are outputting opposite values. And we can recognize tables. Let's answer this question first. An odd function, opposites output opposites. I like that question. We can recognize this table as odd because 1 and -1 are outputting 8 and -8. And it doesn't matter. I could switch the 8s like this, and it's still the same thing. And the 6s are outputting 2 and -2. This is an odd function table. You might want to memorize that a property of odd functions is choice B, that a reflection over the y-axis is equal to a reflection over the x-axis. And again, let's look at that in a picture here, that if I reflect this function over the y-axis and the same function over the x-axis, they're the same thing. And that's what that means right here. Doesn't matter where the reflection is, you get the same thing. Let's look at some more tables. Don't you just love tables? Pause that video and see if you can get that right. This is an even function. The 5s are outputting negative pi, and the 12s are outputting 2 root 3. So what that those outputs are irrationals. Number 15, check that one out. This one is neither, because the 7s are acting odd. They're outputting opposites, and the 6s are outputting the same value. You can't be odd and even. One pair's odd, one pair's even. That's a fact. A function can't be both odd and even. Let's do some value questions. Value questions are best done with tables. Let's build a table. If f of x is an odd function and f of 5 is 2, then that means this, that 5 outputs 2. And then negative 5 would output what? Because it's odd, it would output negative 2, and that negative 2 is the answer. Don't you just love that? Number 17, we're talking about an even function now. F of negative 5 is 2, so that means input of negative 5, output of 2. And so it follows that positive 5 is going to output positive 2 because it's an even function, and that is the answer. You got to be careful here. You have to look at the whole problem. There is an extra negative there. This is an even function. Let's build the table. The table is the table is the table is the table. And so 2 outputs negative 5. That means negative 2 is going to output negative 5. And this right here is negative 5, but you have to bring that negative down. And the answer is negative 5, which is, of course, positive 5. Number 19, let's do a composite function. We have an odd and an even function. Let's do the odd one. Let's do its table. And it is function f. We should know that negative 8 would map to negative 10 because it's odd. Let's do the even function g. We should know that negative 10 maps to negative 8 because it's even. And let's do the composite. This value right here is negative 10. So we are going to replace that with negative 10, and then g of negative 10 is negative 8, and that's the answer. I think we have 2 more problems. Number 20, see if you can identify all the even functions here. Cosine is even, x squared is even, and the absolute value is even. For number 20 at Socrative, you have to put in all 3 of those. I like multiple answer questions. Number 21 and last problem of the day, identify all the odds. See if you can do that. X cubed, y equal x, sine, and I believe that there's one more, the division function. Guys, I had a whole lot of fun today talking with you about odd and even functions. See you later.